First all, I would like to respect to the teacher. We are honored to present our object is supermarket management system for the course database administration. For our team member are Lim In Zong, Tong Riak Chairona, Ratsaiha, Muni Thear, and me Kahayatong. For today, we will cover this table content that are introduction, database design, data population, user grant and access control, backup and recovery, strategy, indexing, and query performance on database server, and the last one is conclusion. For introduction, the supermarket management system is a complete solution for managing all aspects of a supermarket chain, including inventory control, that's managing stock and products category, sales processing, handling customer order and payment, supplier management, tracking restock order and delivery, robust access and security. And technology stack, for backend we use Node.js and SQLite database using MySQL. For front end using React.js, and deployment this website on a host as one machine connected to the database on another machine by Tasker. This is a relational model of our database design, which show the table, primary key, and relationship. Each main entity like product, branch, customer is represented as a table. Junction table like branch, inventory, order item, and restock item handle many-to-many relationship. Order table connect to the customer and the branch, and link to order item for individual product. Payment table ensure each order has one payment record. For role and user, provide security and robust access.
And now, onto data population. So, all the table in our database has been populated by using Python script. Yes, in total, we have 14 tables. And for each table, I created a function which is responsible for the insertion for the table. So as you can see on the image on the left hand side, we have a folder called insertion, which contain all the functions that are responsible for the corresponding table. And then in c.py, I imported that function and just run it. So yes, you can populate the database by just simply running c.py. It's that simple. And yes, some tables are very simple to create because they don't have much relationship or complicated relationship with other table. For example, like branch, supplier. While some other tables are quite tricky to create because they have large amount of data. For example, customer or order item or payment. So imagine we have a million customer, and yes, imagine writing that manually. And order, there are a total of 500,000 order, and each order has two or one item. So yes, so that would create the order item table of about a million entry. And for product, I want to make sure that our table maintaining realism in product. For example, we don't want to have a company that is largely making industrial product to make bread. So yes, we have to make some algorithm to handle that logic as well. All right. And now let's go to the next part.
So hello everyone. So moving on to the user grant and access. So since we are working on a supermarket database admin system, we define 3 direct users to create roles for, which are the system admin, the backend developers, and the business analysts. So for the system admin, they have full access to all tables. They can also create users as well as deleting them, and yeah, they can also grant privileges to users as well as revoking them. So next is the backend developers. Backend developers have development freedom, like altering table and creating index, but they cannot have access to roles and users table as well as financial data to ensure security for the users. And lastly is the business analyst. Business analysts have full read access to all operational table. They can also create temporary views and tables for analysts, but they do not have the permission to modify any data. This is like the view permission is so that for them to use those data to make financial decisions for the market. So moving on.
Hello everyone, my name is Thear. Today I will be presenting about the backup and recovery strategy implemented for our supermarket database system. This strategy is important to ensure data integrity, high availability, and fast recovery in case of an emergency. So our strategy is built around two key objectives. The first one is RPO, or recovery point objective, which means the maximum acceptable data loss in any failure scenario is just 30 minutes. And the second objective is our recovery time objective. It's less than an hour, which means that the database must be restored and be up and running again within that specific time frame. And for our three components, the backup structure, our system uses a layered backup approach. For the first one is full backups. They are performed once daily at midnight using a Python script that runs MySQL dump to capture a complete snapshot of the database. They are stored both locally and on a remote server to ensure easy access. And for our incremental backup, these run every 30 minutes during business hours, which are from 7 in the morning to around 10 at night. They capture the only recent changes using MySQL logs, which can help reduce backup size and time while they still allow a point-in-time recovery. And the last one is manual backups. These can be triggered by admins before a critical update or system changes. This adds a layer of protection during a high-risk scenario. For our organization and retention, all backups are organized by type, full, incremental, and manual. They are also time-stamped to make a version tracking and restoration easier. Our retention policy is full backups are kept for at least 7 to 14 days. Incremental backups are kept around 2 to 3 days. Remote archives are held up for 2 to 3 months, and manual backups are retained as needed and reviewed over time. Moving on to our recovery process. In case of a failure, the recovery process is simple and efficient. At first, we restore the most recent full backup using MySQL client. Second is we apply incremental backups using MySQL bin log to bring the database to the most recent state. And the third is a point-in-time recovery, which is also supported by specifying exact timestamps useful in cases such as corruption or logical errors. And lastly, all backups and recovery actions are logged with timestamps to ensure transparency and traceability. Our security is enforced using restricted file permissions and tail-scale-based access control for connecting to the database securely over a mesh network. For future improvements, we want to implement encrypted storage, cloud-based redundancy, and automated backup integrity checks for further reliability and security.
Today I'm going to talk about index activity format. Let's start with our
index optimization result. We measure query execution time before and after applying indexes to key columns, and we come up with three complicated queries to test it. So the first one is top 5 best-selling products, branch with highest revenue and monthly sale per branch. For the top 5 best-selling products, indexing product ID in the order items table reduce execution time by 28.4%, saving over 550 milliseconds, and actually for the branch with the highest revenue improved by 18.2% using indexes on order ID and branch ID. And lastly, checking for monthly sale per branch was sped up by 15% by indexing the quantity field. This change led to noticeable performance gains with minimal effort. So next, we're going to talk about our database server. For hosting our database, we use Thear VPN application. In order to configure Thear, we install Thear on both the local database server and all remote devices, and configure MySQL to listen on all interfaces using bind address, and created a dedicated MySQL user limited to Thear private IP range. And lastly, we adjusted the firewall to allow MySQL traffic over the private network only. This setup ensured that access was limited, encrypted, and secure. So now we're going to talk about the outcome and benefits of using Thear. So the first benefit is that we achieve encrypted peer-to-peer access using Thear private IP, and the database has no public exposure at any point, and the access remain low latency, stable, and secure across remote user. And the solution was ideal for development use and require minimal setup or maintenance. Overall, Thear gives us a practical and secure way to work with our databases remotely. Next, my teammate will continue with conclusion and demonstration.
So this is the demo of our supermarket system. So first we need to log in by enter the username and password. So right now I'm logged in as admin. And after we log in, we will reach to the dashboard page that will show the total order, total sale, top product, and top 5 product by sale, and also the top 5 branch by sale. And we also can do the full backup by clicking the backup now button, and we start downloading. It may take a long time because it's a full backup. And next is the product. So in the product, we will show the information of our product by name, price, and category. And we also can go to the next page by clicking the next button, or go back to the previous page. And we also can add the product by clicking the button here. Enter the name, price, and choose the category, and we click save. So after click save, it will add the product to the end of our page. So next is the set data. So in the set data, we will show the information of our customer, branch, and product ID. So next is the customer tab. And in the customer tab, we will show the information of our customer like name or email and phone number. And next is restock order. In the restock order, we will show the information of our restock order, and also the same as restock item. And next is the user management. So in the user management, we will show the user of our database like username and role. And we also can add user by clicking the add user button, enter name, password, and choose role. And now we add the new user successfully. We also can edit the user by clicking this and change their role and save. Then it will update successful. And we also can delete user by clicking this icon and click OK. And now the user is deleted. And the last one is profile. So in the profile, we can change the password by enter the old password and enter the new password, and then we click change. So this is the end of our
So in conclusion, our supermarket database system was optimized by introducing indexes on key join and filter columns, this resulting in a significant performance gain. The 3 test queries saw execution time reduced by 15 to 28% within the top best 5 selling products, which query improved by 28.4%. The system's strengths included a decent UI, which is a well-designed database, and readable code. However, we also faced limitations such as reliance on tail scale networking, which adds complexity in like IP management, and our UI is quite lacking a bunch of features like audit logs and fine-grained access control. Data population also required careful handling of foreign key constraints. And for backups, hot backups and binary logs were used to avoid downtime, while secure remote access was handled through SSH and Tailscale. Our future plans include strengthening security, improving the UX and UI, scaling the system, and adding real-time analytics for the support. So this is the end of our presentation. Thank you, teacher, for your attention. And if you have any questions, feel free to ask.